All right, good morning, good afternoon, everyone. Welcome to this series of tutorials. Today we have a special guest all the way from South Africa. You can introduce yourself and what you're doing and where you're studying.
Hello guys, I'm Andisa Jack. I'm doing mechanical engineering at CPUT. Thank you.
All right, thank you very much, Andy. So, all right, so you can just read the question for us, then we see how we move on from there.
Okay. Vectors. We have displacement start A, okay. B, C, and D. Then D is the end. Okay. We'll see exits the front door of a home and walks along the path shown in the diagram above, not to scale. The walk consists of 4 legs with the following magnitudes. A is equal to 88 meters, B is equal to 272 meters, C is equal to 136 meters, D is equal to 186 meters. Determine the magnitude and the direction of Bussi's resultant displacement.
All right, so as I was telling you before, first of all, we need to identify what's on the vector. So a vector has a tail and the head. The head has an arrow. So in this case, this is the vector and its tail there. I think let me use a bright color to show that. So this is the vector like that, and the head is there and the tail is behind there. For this other one, B, this is the vector, the head is on top there, okay, and this is another vector, the tail there and the head there, okay. Then this is another vector and it has the head there on top. So now what we're going to do is we are going to translate the vectors and connect them on their tails. So all the vectors should be connected on their tails. So let me just move this here so that we can see our vectors properly. So we have this first vector here. We can move it. So then we have this second vector here. We connect it to a tail which is there. Let me separate them first of all so that it's easier for me to connect. Okay. All right, so as I was saying, so this first vector is this one, okay? This vector is this one. This vector is this one, and that vector is that one. So now we want to connect these vectors on their tails while maintaining the angles at which they are displaced. So for the first vector, which is this one, we connect it to this one here on the tail of that one. Then the second one is this one. We connect it on the tail there. Okay. Then the third one is this one. We connect it on the tail there. Okay. Then now we need to draw this on an X or Y plane. Right? You know an X or Y plane, right?
Yes.
Yes, so we draw this on an X or Y plane. So this will be the X axis. Let me just draw it properly. I think let me group this as one. Okay, let me group this as one. Then let me draw my X or Y plane there. Okay. Okay, this is my X or Y plane. This is the X axis, and that is the Y axis. Then I'll get my y vector and put it there. So you have to join it on the x or y plane like that. Then we consider the angles, okay? So the angles of each of these vectors. So let me bring on top. So this should go behind. Just a minute, let me just rearrange it properly. So it should go behind and this should be on top. Okay, like that. Is it clear?
Yeah, it is clear.
All right. Now let's identify the magnitude. So the magnitudes of the vectors we are given here. So we have the first A has a magnitude of 88. Okay. So meaning that this A vector is 88 meters. Okay. Then we have B, which has 2. So B is this one here, which has 272 meters. Then C is this one, which has this is what's that, 136, is it? 136.
Yes, it's 136.
And B is 183.
182.
Yes. So now from here, what we do is we also consider the angles at which they are, okay? So we see that this is in the x-axis, but this one is displaced at an angle 30 degrees to the horizontal. So there the angle for this one, for C, which is this one. So this is A, this is B, and C is displaced at 30 degrees to the horizontal there. So the angle there is 30 degrees to the horizontal. Then this one, D, is placed at which angle to the horizontal?
60.
Yes, so this is
60 degrees.
Very good. So this is 60 degrees to the horizontal there, like that. Okay. Now we need to resolve the vectors into components, just as the previous video. So we need vectors in the x component and vectors in the y component. Okay. So we need vectors in the x component and vectors in the y component. Okay. So if you remember, what trigonometric ratio is associated with the x component?
It's cos theta.
Yes, cos theta, that's the x. And on the y component, what trig?
It's sine theta.
Very good, sine theta. All right. So now for each of these, we'll multiply the magnitude times either the sine or the cos of the angle. So for this one, for the first red one, for A, at what angle is it at? For A, what is the
So which one?
A, for A. This vector here, at what angle is it at?
I think it's 180.
No. So always, so this is the positive x-axis, right? So this is the positive x-axis. So that is where we start from counting the angles, okay? So meaning that if this is the point where we are starting to count the angles from, then what will be the angle of A degrees of A? Did you get my question?
No. Can you repeat it?
All right. So I'm saying when considering the angle at which a vector is, you always start from the x-axis, the positive x-axis. So here, this is where you start from. So this is where you're starting from. So this point is 0 degrees. Then you're going clockwise like that until you get to whatever angle you have. Okay, so whatever angle is on the positive x-axis has an angle of 0 degrees. So this angle here, the angle for this vector is 0 degrees. So we're going to write 88 cos 0 degrees. And this side, what are we going to write?
The angle starts from point A. Am I right?
Yes, very correct.
Then, so our angle is going to be 0 because this is where the angle starts.
Yes, very good, very good. So here on the x, it will be 88, which is the magnitude, then cos 0 degrees. Then on the y side, what are we putting there? It will be what?
It's 88. Cos, I mean sine 0.
Very good, sine 0. So now we go to the vector, we can go to this one, which is vector D. Okay, we can go to vector D. So at what angle is vector D at? So remember, the angle starts from the positive x-axis until we reach there. Okay? So the angle starts from the positive x-axis until we reach the vector that we want. So what do you think that angle is there? What would be this angle here?
I think you are going to minus this angle, which is 60 degrees from 180.
Very good, very good. So yeah,
180.
Yes, that's good. So that's
120.
Yeah, so this one will be 183, which is the magnitude, cos what is the angle there? What would be the angle there? 60 minus 180.
120.
Very good, 20. Then we just duplicate the same thing here with the sine now. So this would be 183 sine 120 degrees. Then now we go to C. Okay, we go to C. So remember, the angle is from the positive x-axis until we reach the vector that we are going to. So C, what is the angle there? All right, so you said the angle is what?
210.
All right, so we'll say 136, which is the magnitude of C, then cos 210. Then this other side, it will be 136. You said 136? Yeah, oh, okay. 136 sine 210, right?
Yes.
All right. Then the last one,
Yes.
this one, the last one, B.
B. So going to be 272. Cos so okay. So this angle is on y-axis. So it's going to be, I think it's going to be 270.
Very good. That is 270. So we just replicate the same thing here. We say 272 cos or sine 270. Okay. Any questions here?
No.
All right, so now here we need to simplify each of these so that we find the x component and the y component. Okay.
Okay.
Yeah. So what is so I hope you have a calculator somewhere so that you'll be very fast.
0. It's 88.
Okay, so this would be
88 meters.
okay, 88. Then here cos 120 times 183.
It's negative 91,5.
Negative 91.5. Is it 91.5?
5. Yes.
All right. Then the next one. What will be the next one?
So the next one is 136 cos 210 mos.
It would be what? 136? Or 136 cos 210
Cos 210. So it's negative 117.
like this?
Yes, 0.78.
0.78, like that?
Meters. Yes.
Okay. Then the last one, that will give you a 0, right?
It's 0.
Yeah. So now we add. So what are you getting when you add everything?
What am I going to? Okay, so 91. I will say. I can go connect. All the x components. The answer is negative 121,28.
121.28. Okay, that is the x component.
1.28
All right, so we found our x component.
meters.
Okay. Then now let's find the values for the y component. So here 88 sine 0.
So it's 158.48.
0.48.
Yes.
Okay, then the other one 136 sine 210.
Okay. So it's negative 68.
Negative 68. Then the other one.
It's negative 271.
Not
Oh, sorry.
negative 272.
It's negative 272.
Yes, yes.
Yes.
Yeah, so now let's add the y component. So the y component, what are we getting if we add everything here? 0 plus 158.48 minus 68 minus 272.
155.
You said it's negative what?
181.
Point
55.
55. Like that?
Yes.
All right, now we come
Yes.
to all right. So there, that will be negative. Okay, so that will be negative there. Okay. So now from here we go on to finding the magnitude and the direction. Right. So there it's supposed to be negative. So the magnitude is just the resultant, which will be equal to the root of the real part squared plus the imaginary part squared, or the x component squared plus the imaginary part, or I mean the y component squared. And in this case, we're going to have the x component is negative 121.28. We square that, then plus the y component, which is negative 121.55. We square that, and we find the value by simplifying. So you say negative 121.8 in brackets, then you square, plus in brackets negative 181.55, you square, and you get the answer of. So when we simplify everything, we're going to get 218.30 meters. So that would be the resultant, and we can find the angle or the displacement, the direction, which is theta is equal to tan inverse of the y component over the x component, and which is just equal to tan inverse of the y component is negative 181.55 over the x component, which is negative 121.28. Okay, and when you simplify that, your theta would be equal to 56.25 degrees. Okay, so that is your direction. So you will also be asked to maybe sketch the graph of the resultant. So on the XY plane, let's use black to represent the XY plane. So if this is your XY plane, you need to look at the directions in terms of the negative. So this is negative x, then negative y, so it will be in the third quadrant. So this vector will be in the third quadrant, so we can draw it in the third quadrant like that. So that would be the vector in the third quadrant, like that, like that. Then we can also put the direction. So this is positive 56.25. So positive 56 would mostly be there. Okay. If it's negative, if we find the negative, then it will be the opposite direction. So if the direction was negative, then we'll start from here going to the vector like that. So, but in this case, it is positive, it will be like that. And the magnitude is 218.30, and the direction is 56.25 degrees. And you are done. So that is about it. Have a great evening.